Welcome back to this module covering techniques for modifying strings. We'll cover several modification techniques in this module. We'll learn how to trim whitespace characters from strings and handle whitespace using regex patterns. We'll convert the case of strings or characters. We'll learn how to replace characters and how to remove characters. We'll conclude by learning about and applying regex lookarounds to provide assertions during matching. In this demo, we'll begin by dealing with leading and trailing whitespace characters by trimming them from existing strings. We'll then learn how to convert the case of characters and strings using methods on the string type. Returning to the category class, we'll ensure we implement the last requirements and turn our final unit test green. We'll begin by dealing with any whitespace in the source string. One of the most convenient ways to strip whitespace from strings is to use trim methods. There are three related trim methods we can call on a string instance. Trim start can be used to trim occurrences from the start of a string. Trim end can be used to trim occurrences from the end of a string. To trim from both ends, we can use the trim method. Each of these methods has three common overloads. We'll study these using the trim method. Calling trim with no arguments causes any leading and trailing whitespace characters to be trimmed. When we provide a character as an argument, trimming will remove any occurrences of that character from the start and end of the string. We can also provide multiple characters that should be trimmed. Any occurrences of those characters will be trimmed from both ends of the string. When characters are trimmed, these methods return a new string instance that no longer includes the trimmed character or characters. There are several ways we could tackle whitespace removal in this demo. We'll start by calling trim on our source string to remove any leading and trailing whitespace that may be present. The return value is a new string instance where no whitespace will be present at the start or end of the string. Combined with a use of a range already present in this method, we can now be assured that we have parsed a category code without whitespace. Even if whitespace exists after the code and before the colon, we'll ignore it because we're extracting the first 6 characters from the start of the trimmed source string. Our existing validation will then detect if any characters are invalid for use in the final category code. We still need to deal with the potential of whitespace in the category description. Our use of trim on the source string will have stripped trailing whitespace, but we may have whitespace between the colon and the description that we still must consider. After extracting a substring from the position after the colon character, we can add a further call, this time using trim start. We can return to the category tests to validate whether our changes cause the last remaining test to pass. I'll right-click on the try parse test method and run the tests. After a few moments, we see no failures, and we can confirm that our updated implementation works as expected. It's worth another reminder that strings are immutable. By trimming, we are not affecting the current string instance, but creating a new one. Let's quickly review the modifications that we've just made. Here's an example category, which includes whitespace. Spaces are illustrated here with the red period characters. We begin by calling trim on this string, which removes the leading and trailing whitespace. We then find the index of the colon character. For the category code, we used a range to extract the first 6 characters from the string. This has the effect of ignoring any trailing whitespace and produces a new string containing the code we wanted to parse. To extract the description, we started a substring from the position after the colon. To remove any leading whitespace from that extracted substring, we called the trim start method, leaving us with the parsed description and no whitespace. We've been given an updated requirement, that codes should be normalized to contain only uppercase letters. Our current implementation parses irrespective of casing. Let's add a test case that will assert that we return an uppercased code after parsing. The source string that we'll test contains a lowercase category code. We expect the parsed code in a result to be converted to uppercase. The description should be engineering with no case modifications. We'll set the final test argument to true because we expect parsing here to succeed. If we execute our test, which will use our updated test data, we see that it now fails. We can see that the parsed value is currently lowercase and therefore does not meet our new requirement. Let's head back to the implementation to fix that. After extracting the source string's code portion, we can perform an operation to convert the casing. Two methods exist that can be used to convert the case of characters within a string from lowercase to uppercase. ToUpper has two overloads. The first requires no parameters and returns a copy of a string where any lowercase characters are converted to uppercase. To ensure cultural rules are considered, we should generally use an overload accepting a culture info. In situations where we are dealing with data that does not need to be treated in a culturally aware manner, we can opt to use ToUpper invariant, which applies invariant culture casing rules. We'll reassign the value of the category code variable with the result of the casing change. We expect the characters in the code to be UK English letters. This is a situation where ToUpper invariant is a suitable choice, so we'll invoke that method on our category code string. Invariant culture will treat English letters correctly. This single line of code should be sufficient to meet our requirement. This time, all 10 tests pass because our updated implementation ensures that any parsed category codes have the expected casing.